All right, awesome. Vasileos, I see your question here. Today, there is no collab sheet. So we're going to be doing something a bit different, but we will be reusing some old code that you guys have seen before that are readily available in our Git repos. But today's is going to be all about process and getting to know your tools inside the Amazon Web Services cloud here. So I'm going to give it one more minute for everyone to trickle in here, and we'll get started. But there is no collab sheet, no code to worry about. I'm throwing way too much new stuff at you guys today to add code on top of it. However, in future labs here, we'll build on this and we'll write some code in the cloud and train on these things here. And again, for anybody looking for the series notes here, those are in the tiny URL link that you will see dropped in the chat window here. Same one we've been using all throughout. Today we'll be adding, obviously, this slide deck, and when the video is done, this recording here. So you can kind of go back and study this at your leisure. Again, I do have the question and answer panel up, so feel free to use that. Makes it very easy for me to track questions. If you do have a question, and I'll certainly make sure I get to it. And I've got the chat window up as well here. So if you guys have any questions, comments, please keep them coming. It's always very helpful when you all participate. It's really made these classes go wonderfully so far. So let's talk about what we're doing today. As a quick review, in the last classes, we learned about TensorFlow and how to build deep neural networks with them. We got to see some of the common architectures, some of the common parameters we need to worry about, some of the common challenges and data sets to benchmark with. In the second class, we focused on building heavier duty neural networks, specifically convolutional neural networks for feature extraction, which is a more advanced layer, much more computationally intensive. And we saw just how long those training times could take if we're on a GPU, or excuse me, on a CPU-backed machine. So Colab came to the rescue. It provided us with some free GPU and TPU support, and we saw just how great that speed up was. In our next class, in our third class, the last class we had here, we tweaked some more of our methodology here by learning about how we can use things like TensorFlow callbacks to add our own behavior to our models here, to do things like intelligently decide when to reduce our learning rate, that very pesky, very important hyperparameter here, when our model plateaus, how to use things like TensorBoard to examine our training and see how things are going, or just all the other cool things we could do with that too. Early stopping, I think, is probably my favorite here. And we'll see today why it's so important, because in the cloud, every extra minute of training is money. So early stopping is one of these things that we'll see today. You've heard me mention in the last class, early stopping will save you money. Today we'll see how. Okay, so let's jump right into it. So we just reviewed kind of what we talked about in the previous classes here, and today we're going to pivot a bit here. And we're not going to be writing a bunch of code. We've done a great job writing better and better code and more professional code that is doing wonderful deep learning tasks here. But we're at the point in a machine learning engineer's kind of workflow and life cycle where we have to start to think about using professional tools. Colab is great for practice problems. It is great for studying. It is excellent for prototyping and things like that. But eventually, you're going to have to get into one of the cloud providers, because that's just what makes the world move today. So we're going to talk today about how deep learning works in the cloud. We're actually going to demonstrate some of the major technologies you'll use inside the Amazon Web Services tool chain here. Now, just a quick aside, some of you all might be panicking right now. You go, wait, this isn't useful. My company is on Azure or GCP or Paperspace or FloydHub or any of those other ones. That's totally fine. We have, so the general concepts that we're going to cover today about how to, what we're using, why we're going to want to use it, the types of decisions we make, where the data lives, what's doing the processing, all that good stuff is pretty interchangeable across all the cloud platforms here. AWS has the largest market share, and personally, it's my favorite. So I'm biased, and I'm going to go towards this one today. However, if this is something that you all are struggling with, and it's quite common to be able to understand the theory behind machine learning, but struggle with the tool chains and the productionization, the DevOps, and all this other good stuff here, Elephant Scale is well equipped to help you. We can help in any cloud platform. So do take any worries you have with a grain of salt here. If we're talking about AWS, just try and translate and think, okay, what would this look like in Azure when we're using this, or GCP? Because it's going to have the same things. They just have different names, but the general structures are the same. And again, if you do need help training, anything like that here, it doesn't matter the cloud platform, Elephant Scale, we can certainly come to help you there, okay? So without further ado, let's jump right into it, okay? So we talked about that. So let's talk about some of the benefits of why we would want to work in a cloud platform. So I've met many a burgeoning machine learning engineer who thinks, listen, I got a pretty powerful laptop. I got a MacBook Pro. It's $2,600. This thing's screaming fast. Why can't I just build my models on this? And the short answer is you could. There's nothing stopping you here. But you're going to have a pretty low ceiling in terms of what you're going to be able to accomplish, right? We saw this in class 2. We saw that, well, when we run into a lot of data and we have very complex models, then it's very, very hard to end up, dealing with these epochs of training times. Could you set your MacBook to run in a corner and know, hey, this is going to take 30 hours and just don't touch it? Yeah. Will it work? Maybe. You'll see kernels fail and things like that. It's generally not a great idea here. So this brings us to why deep learning is awesome in the cloud, because we can make use of more powerful machines. Now we're going to talk about some of the routes people go, and it's not always the cloud. If you're in a company that is doing a lot of dedicated deep learning, then there are use cases here where you might be better served. That it's essentially going to be, you might be better served with like a dedicated machine that can do all kinds of great stuff. But we'll see that it's hard to scale those, right? And the startup cost is very expensive. The cheapest ones are still a couple $1,000s here. So we're going to see how the cloud allows anybody, whether you're an independent developer with a good idea, or you've got a massive, largest company in the world behind you. We'll see that anybody can start up and hit the ground running with deep learning in the cloud here, and that you don't have to pay these exorbitant startup costs that come with buying heavy duty hardware. Okay. So essentially what we're going to find today is that we can no matter what direction you go here, no matter what area you're arguing, what about cost? What about scalability? What if my needs change? What if I need to incorporate all these different tools here? I trained the model. What if I need to ship it? We're going to find that the cloud is generally your best choice in all of these situations. That there might be individual situations where, hey, this might be a better choice for you. But overall, if you're not using the cloud, I cannot encourage you enough to do that because it is going to make your life a lot easier. Hopefully we get a feel for that today. I see a question here. Cynthia, I'm so sorry here if you thought this is class 1. We do have those recordings available. We have a lot of people drop in midway through these series here. So yes, go right ahead. I'm sorry, the schedule you see there is for our future upcoming classes. Apologies for the confusion, but you can certainly watch this video when you've made it through the other ones here. We won't be talking about any deep learning theory today. So this is actually a good one to jump into. Yesterday, like last class would have been a bit more challenging because we'd have been writing code, wait, what's that? But we're kind of taking a break and taking a step back, talking about this at a 10,000 foot view today. So if you'd like to stay and watch and ask questions and participate, this is still a great choice for you. You probably you won't be behind the 8 ball here. So apologies for that confusion. We're glad to have you. If you do have any questions, feel free to ask them or shoot us an email once you've watched the other videos, and we're happy to talk through them with you. Okay, so let's talk about how some people decide to do deep learning. You might use a physical workstation, right? We've learned so far that what's really important is a solid GPU, or better yet, multiple GPUs, and a lot of memory. You need a lot of RAM to do deep learning, because you not only have to fit this massive model with, you know, many, many millions of parameters inside RAM, but all your data too is going to have to fit there, right? So you're gonna have to read this in and feed it to the model and all that. So people have built some pretty heavy duty machines for this here. And what's nice about this is you pay a one-way cost, right? Then really all you're doing is you're paying for the electricity you're running the darn thing. So these are some examples of some of the best in class desktop workstations people use. They're from a company called Lambda Labs. And they are absolutely awesome. But as you can see here, they're wildly expensive, right? You can also go the other route of building your own machine and starting to string together GPUs, but it's very hard to do. I did that myself back before I learned about the cloud, and wasted a good couple grand there, and ended up in all kinds of deployment hell, where I was trying to get this DLL and CUDA and all these other things installed on my path variables. It's hard to do, right? So these are great if you guys are going to run and do the same kinds of tasks again and again and again. This is something where a company like OpenAI is going to have, just everybody has one of these at their desk. Because, you know, when you're doing deep learning training as much as they are, then it makes sense. Then the economy of scale makes sense, where, you know, their budget of how much training somebody might do in a given quarter or a year will probably be more than $6,000 because they're doing that much. This is, in our experience, not the norm. This is not what most people are running into. This is for this is only useful for companies that are very, very deep and very, very mature into their deep learning and you know, ML AI strategies here. So there's the large startup cost. The other issue is that these machines don't scale well. You know, we see that you know, sometimes you might be training a model and you need exactly this much memory and this much power, so you buy the cheaper one, right? But then a new model comes out. This is something, if you practice natural language processing, we've seen the size of these models has become massive. If you do reading on this area, you're interested in models like BERT or transformer models. They're trained on all of Wikipedia and all these other massive data sets, and they are literally as large as we can fit in memory on servers, right? So if you bought one of these in, you know, let's say August 2018, you had a great machine for doing things like working with word vectors, or, you know, training text classification pipelines. And then the world changed in October 2018 when this new model was that, and suddenly this probably isn't big enough. And you need to be using servers in the cloud. If you wanted to take one of these machines and add additional cards, that is something you could probably do. I'm sure there's spots on the motherboard for it. But that takes a lot of money and a lot of skill. And it's certainly not great, because we know this field is going to keep evolving and evolving quickly. And having to change our hardware layout every time is expensive. It's much easier to use somebody else's machine for this here. Let's see, I saw somebody raised a hand. If you do have a question, feel free to just type it in the Q&A session here, and I can answer it as it comes through. Or the chat window is fine too. But I don't have a way to see who raised the hand, so apologies for that confusion. This is one of the reasons that, you know, people used to go this route. The cloud has quickly subsumed all this here. So let's look at, you know, why cloud is better. From just the talking about cost, not worrying about scalability, not worrying about all these other things here. Just by cost, it is absolutely amazing. To use a server with a couple really powerful GPUs, we'll see today, the cost is about $1 an hour, right? I don't know how many hours you're doing in deep learning. I work in deep learning full time. I do not do 6,000 hours a year of training. So just in itself here, I probably don't do half that. So just by itself here, I'm getting a much more powerful machine. And I'm getting to pay it as I use it, rather than what we saw the cost for buying heavy duty machines, no matter how much I'd secretly like to own one of those. it just makes more sense to use in the cloud here because I have heavier duty machines and I can pay for only what I use. So if I want to run an instance and keep it up and running, I'll pay for that. But again, the cost for that on a running basis, you typically bill by the minute, and it's phenomenal. Some platforms bill by the hour, some bill by the minute. It's absolutely great here to be able to do that and only pay for what we're using here. We'll see that there are many different sizes of machines as well, right? It wouldn't be very helpful to us if, you know, there's one type of server, it's got all this power, all these cards, and I don't really need all that. Sometimes I want to prototype something or do some data cleaning. Maybe I just need to use a machine with CPUs. I don't need GPUs. That's quite common, right? And again, this is, we're talking about this in the context of deep learning, but remember, this is how people are, you know, pretty much the only game in town for hosting websites and web apps and services and databases now too. So the same constraints apply there, right? That we need only what we, you know, you generally want to buy only what's needed to do what you're doing well, right? You don't need to pay for a bunch of extra power your computer's never going to use. So being able to dial in and say, oh, the problem I'm working on, I need TPUs. This is a big one. And it's going to be distributed. Or, yeah, that's the deep learning one. The epochs are big, but I don't need the biggest thing here. I need GPUs. Or a more common one for me is, what's the size of our data set and what's the size of our model? I generally always need a GPU, but how much RAM I need changes on a problem by problem basis, right? And you will see there's ones that have many GPUs or TPUs inside the server, but they have varying levels of RAM, right? And then obviously the more memory they have, the more expensive it is to use that here. But we'll see these things range from anywhere from, like, you know, a couple cents an hour to something like $5 an hour, depending on the power we need. Even $5 an hour is still a manageable cost to most companies here. If you truly need something, if you're doing something that intense, then the cost to do it is almost laughable compared to what it would cost if you're going to build your own supercomputer to do this, which is, you know, $250,000 at minimum. Some of the other benefits here about doing all this stuff here is, aside from cost, is that we are already on the platform that our engineering team is using. So typically we're software engineers, you know, we have software engineers. Let's see here. Suji, I see a question here. You say, I only see slides. No, I'm just showing slides right now. Was there something else you're mentioning here? Oh, sorry. No, no apologies. No, sorry for the confusion, y'all. So essentially, it's a one-stop shop in that we're going to be, you know, typically we do our work in a Jupyter notebook. You know, a data scientist job is done when you have basically built an MVP, a minimum viable product, a proof of concept for whatever predictive analytics task you need, at least in the context of machine learning. And then you hand it off to an engineering team, and that engineering team has to get it to play nicely and work with their current system, right? Whether it's an app for a phone or a web app or whatever they're doing, right? And typically those all live on a cloud platform nowadays. The days of building your own server rack and hosting it in a closet that is not air conditioned well enough inside your company headquarters, those days are long gone, right? It's much, much cheaper, more resilient, more reliable, safer to do this yourself. So this is great because it reduces the complexity of having to use multiple systems, right? So you can take things that we'll see that all the tools that are in AWS play quite nicely. It's very easy to go from data that is an S3 bucket to an EC2 instance that we're then going to push, and we're going to scale, and we're going to make sure we're using CloudWatch to monitor and all kinds of good stuff here. So all those tools are available to us, and it makes working with our teams that much faster and easier. Finally, one thing that I think is very nice and a breath of fresh air to see here is that from the major cloud providers, there's always been this worry of like, okay, well, when I buy from this vendor, I'm now stuck with them. The cost to move to a different platform is wild. I just can't, you know, you're kind of stuck, and if they make bad decisions, it affects you, and you know, you're kind of handcuffed to a vendor. That's generally the case with a lot of software issues. I'm happy to report that is not the case with cloud providers. it is quite easy, at least from a deep learning perspective, to say, you know what, we're done using Azure. I want to move to AWS here. Let's train our models here, things like that. Or can I train my models by pointing it at this bucket or that? Yes, you can do all those things. So it is quite easy, and it's got all these benefits, and the typical risks we see, they're just not there. Okay. Now, this is something I find wildly useful, because you heard me talk about there's all kinds of different ways to rent this server or that server in terms of GPU, TPU, memory, things like this. So we have the ec2 instances.info website. I highly encourage y'all. We will drop this in the chat. Bookmark it. This is going to save you a ton of time. Unfortunately, it is not very easy to find this price list somewhere inside of Amazon. But this website is awesome in that it pulls and kind of scrapes it all down here. And these are all the different kinds of machines and configurations you see. We see the on-demand cost. We see the reserved cost, how much memory it has, what the name of the machine is that you'll need to search by, right, when you want to use this inside of AWS. And then certainly if it's running on Linux or Windows, and all that good stuff here. So typically we're going to be using something like a P2X large is typically where people start with here. So let's type that in. Let's say P2. Let's search here. I'm sorry, I'm over here. So we're going to do P. Yeah, here we are. And like a general purpose GPU extra large is generally the smallest and cheapest GPU one you're going to get here. Still certainly big enough. We see it's got 61 gigabytes of memory, more than enough for most things we need to do here. And then you have some of these really big ones, and these aren't the only ones. The ones that start with P aren't the only ones that start with that use those, but they're phenomenal here. So we can see the costs here, and for instance, if I wanted to use it on demand, right, then I would pay about 90 cents an hour. That's not bad at all. That is not bad at all, especially when you consider that something like if you were going to build a machine, a desktop machine that had 64 gigs of RAM, that in itself is going to run you hundreds of dollars, and then you're going to need a couple GPU cards in there. If you're going to run, I run like a 1070 Ti from NVIDIA, and those are like 450, 500 bucks now, depending on the ones you get, because all the crypto people have just pushed the prices so high. So you really can't beat this here. It's absolutely wonderful to move through it here. So check out ec2instances.info. This is a great way anytime you need to know the prices. Looks like this is scraped, and it tells you the last time it was done, which is awesome. So back to where we're at here as we're moving on. So we've talked about you saw there on-demand instances and reserved instances. There's three types of instances. And an instance, again, just to make sure I'm using the nomenclature correctly here, make sure everybody's comfortable with the terms you're going to see and hear a lot here. An instance is an EC2, or an Elastic Cloud Compute instance. What it basically means is the computer you're renting in the cloud, right? The cloud is just somebody else's computer. So whatever server you're using inside of the data center, wherever in Amazon. So you see there are reserved instances where I'm basically paying, something like 90 cents a minute, but it's mine. Nobody else can use it, right? And it's safe. It's safe. It's going to be there when I need it. It's always there. So that's a reserved instance, right? You have on-demand instances too, right? Which are going to essentially be like, hey, I need it now. And this is just what it costs and typically those are the ones you don't leave running. When you're done with them, you turn them off, right? And because you're not paying longitudinally for it, right? You're not buying it a month at a time. Then it is a bit more expensive, but only marginally so. We saw, if we went back to the EC2 instances one there, I think it was 64 cents an hour for a P2X large reserved. But again, you have to keep it for a while, or just 90 cents an hour as you need it, turn it on, turn it off, great. The third option here are spot instances, right? And spot instances are awesome. We are not going to go deeply into this. You could really go down the rabbit hole on this. But spot instances basically allow you to set a bid price, right? So the price for, Amazon has, think of all this computing capacity, and for that computing capacity, they're never at 100%, right? No one's, it's never where like Amazon says, sorry, we can't sell anymore. We're totally full up right now. They have so much capacity. However, as that capacity, if it's at 20% utilization versus 80% utilization, will that change the price? Absolutely, right? So spot instances allow you to play this almost like a stock market or an auction. You can say, you know what, I will bid, I don't want to pay anything more than 50 cents an hour for this sort of instance. Let's say it's a P2X large. Well, sometimes the price of the P2X large probably is below that. Other times it is not. Other times it is more expensive. Maybe you would think peak hours, right? So I would say, Monday at 1 p.m., there's probably a lot of people using these things here. However, if you're doing your training, you schedule this and you say, well, actually, I'm going to do it on this server, this region, and I'm going to do it. My training, I want it to run from 10 p.m. to 2 a.m. here. You can set that and kind of say, well, I'm going to set a bid of this. And if your bid is the highest, if it's higher than the current cost, you get that spot instance. And you get that spot instance for that price as long as the price doesn't rise above it. So the second, if your bid's 50 cents an hour for a P2X large, the second that price goes above 50 cents to 51 cents an hour, you lose that instance. And somebody else who bid 51 cents gets that instance from you. So we can see there is a way to save money here, but you also have the issue of like, uh-oh, my training got interrupted because I got outbid or something like that. So this is something that I see companies do really well in kind of the ones who really pay attention to this and do it maturely, especially because this is where data scientists and machine learning engineers shine. You can do some time series forecasting and say, what do we think is a good price here? What is a good bid for this? Do some analytics. And I've seen companies reduce their overall spend by something like 50, 60% on this here. So spot instances, I would be remiss if I didn't mention them. We're not going to go deeply into them here. You will find the link to the AWS documentation here. And again, it's very easy to Google. But those are worth knowing about, and those are worth paying attention to as we learn here. Now, functionally, the things you're going to see today, using S3, using an EC2 bucket, using SageMaker, those are going to be the same. There's no difference in the process once you have that machine rented out, depending on the instance type, right? What we're doing, that's going to be agnostic to all this here. This is just, we're talking about how to pick how you buy it or rent it, I guess is a better term here. So without further ado, let's jump into AWS, okay? So I have logged into AWS in the management console. We're not going to talk about like how to create an account. It's all very simple, and Amazon will do a better job than I could with that here. But let's assume you all have an AWS account here. I am in the North Virginia one here just because that's what it logged me into. You can go to any of these. Just know that if you do some work in SageMaker on US East 1, and then you switch over to US East 2, you will not see your work. The work is local to whatever areas or regions you're in. So pay attention to that. If you're new to cloud, working in the cloud, essentially these are data centers, right? And the computers here don't know what the computers here know. I mean, you can, not by default. I'm in that one here, which is where I need to be. And we have all of these different things that Amazon AWS provides for us here, right? And you'll see the same if you log into Google Cloud or Azure or anything else, right? So what do we need? Well, there's three main things we're going to talk about today, okay? That's how to spin up an S3 bucket. That stands for Secure Simple Storage. And that's typically the catch-all where you store data on AWS. Again, Azure and GCP have their own versions of this here. It's just your data store. And then we're going to, so we'll talk about how to store data there. We'll talk about how to spin up an example S3 bucket. We are not going to go and push it through the cloud here. This all gets very in-depth. Amazon is great in that there's three ways to do everything. You can either do it through the GUI like this, like through the web portal. I can do it through an Amazon command line interface tool, like the AWS CLI, so I can do it through a bash terminal. or I can do it directly in my Python code using their SDK, and it's called Bodo 3. So I could create a bucket for Amazon S3 and name it and store stuff in it. And I could do that using drag and drop through the management console. I could do that through the command line tool, or I could literally write some Python code and do the exact same thing. All of these are valid methods here, and whatever's most useful to you, you kind of have to experiment and understand your own workflow. They also have all kinds of trainings and demos down here that'll get you started with the basics here. And I really encourage you to go through some of these here. The 2 to 3 minute things will give you a general understanding of what an EC2 one is, how to launch it, and things like that. And then, when you're ready and you start to run into the problems you can't solve just by Googling your own tutorials, that's when we'd love to come in and help you. Okay. So I'm going to search for S3. And there it is. Okay. And I'm just going to click it. It's going to open this up for me. And these are all different buckets that I have created, and I can store any data in a bucket, right? And it's really fast. It is super fast read through and all kinds of good stuff here. So this is a wonderful place to store your data. It's always better to store your data in the cloud, which again, you can lock it down as deeply as you want to. It's very, very secure. And I believe AWS is also things like HIPAA and FERPA and all those other compliances. They got all that too. So you can store your data there without having to worry about it. So typically we need to create a bucket. So again, we're just going to do the GUI version. But let's say we wanted to create a bucket. We're going to create a bucket. We have to give it a name. So I'm going to call this ES Training Example 1. I have to choose a region. So again, like where it is, is it the data center in Stockholm or the one in here? I'm going to choose the one in US East 1. Sure. This is basically, can everybody see this bucket? Which there are some public buckets. It's totally common for, if you're a nonprofit that stores a bunch of data sets, you can do that there, right? You can block public access. You can block access to only certain people. You can block access to people that are in your organization, everybody, or be selective with it. There's a ton of good stuff there. Typically, as a machine learning engineer, this is not something that you will have to be very deep on in terms of understanding IAM roles, right? And that's like identity access management to say who can see what and what permissions do they have, and it gets very, very granular. And typically, if you're in a company that is using AWS, you have somebody who's going to specialize in that. Typically, it's your SREs or your security people, right? Who are going to be your AWS or your cloud wizards, okay? We see some advanced settings. We don't want to touch any of these here. But all we have to do is create a bucket. And we'll see that it takes a little time for it to spin up, okay? And we see, so it's right here, and we're good to go, right? Successfully created, okay? Now, I can click on that bucket. And it'll open it up here. And this is an empty bucket right now, right? And if I wanted to upload something, I could just click upload. I could, pretty much drag and drop things in. I can set object properties, for instance, who is allowed to view, what it's going to be like, storage, things like that. And then object permissions, who can delete things, who can access things, all that fun stuff here. You can see what access points people can do this through. So for instance, if you want to expose it to the web selectively with a password or a wide open, or you want to lock it down completely, you can do all that. Now, this is nice to have. It is not something that you're going to need to know deeply for today. We will use this in a later tutorial as we kind of show examples of a full end-to-end workflow. But I wanted to, it's too much. It's a bit too meaty of a task to explain all these things, what they do, how you'll use them, and then do them all at the same time. This would be a 5-hour training. So today we're just going to kind of talk about what they are. You get a feel for them. Hopefully you all will take some time to create a free account. They do have a free tier to let you play around with these things here and get a feel for it. And then on, when we get to this in a future training here, we'll really be cooking with gas and you'll be able to follow us quite easily and work with all this here. So short answer is, the first thing we need here is where's our data live? This is where we live. This is where it lives. We've just seen how to make it live there. This will allow us to have, when we do something like, train data from an S3 bucket in an EC2 instance, this will make it much faster than us uploading it because it's stored in the same data center And the throughput from an S3 bucket to like an EC2 instance is something like 25 gigabits a second. It's insane how fast it is. So it's worth uploading your data here, and then it's much faster to use this later. Now, again, you do pay for this to sit in the cloud for as long as these S3 buckets exist, but you know, you're paying by space, and it's typically not a lot. Storage is cheap now. Storage is really cheap. So I'm going to go back here, okay, and we've gone ahead and we've looked at S3. So that's where we store our data, but where are we doing our actual computation? And that's something called an EC2 instance, okay? Now, an EC2 is just a virtual server in the cloud, okay? This is a virtual computer you are tunneling into, you are renting access of here. This is what my page looks like. I have some things running right now. Hopefully nothing running beyond what I'm, it doesn't look like it here. You will see that if you leave some things running, you're getting charged for them. So you always typically want to check, did I shut everything down correctly? So this is an EC2 instance. We can launch an instance quite easily. And the configuration here does get a bit confusing, right? So essentially, we're going to launch a machine, and it's going to use Docker, right? It's going to use Docker to understand exactly what should this machine look like. That's going to load the operating system. It's better than virtual machine. It's a Docker instance, right? It's a container. So do I want it running Linux? Do I want it running Red Hat Enterprise Linux? Do I want it running Amazon's flavor? All these different things here. Now, there are a ton of different ones here. Now, there's one that's going to make our lives a lot easier for this here, and that is the Deep Learning AMI by AWS. So if I just type in deep, and I'm here, I'm sure it'll pull right up. Yep, bingo. Okay, AWS Deep Learning AMI, and I can choose what flavor of Ubuntu I'm using here. I can do the base one. I can do the one with Conda on it. It's all the same. I mean, there's the amount of configuration, the options you can have here is phenomenal. It is really, really good stuff. Okay, and it tells you what's on here, right? So we can see, comes pre-built and optimized for deep learning on EC2 with the CUDA, cuDNN. These are the drivers that allow your model to talk to the GPUs and do all kinds of fun stuff here. Popular frameworks such as TensorFlow, MXNet, PyTorch, Chainer, Keras, all the good stuff you need there. It's all there. There's some that do elastic inference, which we'll see. Now, this is if I want to do this configuration myself. I'm going to pick the top one. And what this does is it means that I do not have to do things like load up this and then install an operating system and load up Conda and install pip and download all the libraries I want and the packages and then do it. This is good to go. I can fire this up and then I can do like Jupyter Notebook and it'll fire up and I can do import TensorFlow and it's there and it works. So this is great because it is a pre-configured Docker container that we can start from. And what's nice about this is you're always starting from the same place. It's got all the tools you need. What if you do need to install something? Well, you can do that too. It's your container, right? It's a copy of it. So like for instance, if it doesn't come in, I think these don't come with like matplotlib. Well, that's a very easy pip install matplotlib, something like that. Now they tell you, now again, using the AMIs itself are free. You can download an AMI, you can run it on your own machine, you can do it, you know, on Docker desktop, you can do any of that, okay? It's basically saying, so if I want to, so we see the software charge is 0, and then this is if we wanted to pay, you know, some of these are not free. There is a marketplace, and some people put out, some companies put out, you know, things where, hey, here's our software, you can pay to use it, and, you know, you'll see how it kind of totals the cost. As we can see, you know, if we're doing a T2.small, it's 2 cents an hour. And so it's 2 cents an hour total, right? So we would be using something like a, let's get down to, where are we? Here's like a P2X large with this. There's our 90 cents an hour for an on-demand instance. Great. This is a really easy way to do things here. So I can just continue and I can move through this here. Now, I don't have the permissions set up because this is I'm on the free tier account. I created an account just for this. To show you guys here, and AWS does limit some of the things you can do with that, but essentially, once you've got this set up, and certainly these are problems you won't have within your own company, And you can kind of work through these things. So here we go. Here's an instance type. And I can literally just say like, well, let's go down here and I want a, we're getting there. I think it's generally towards the end. The fast ones. What am I doing? I'll do a P2. There we are. So I'll do something like this. And I'd say, yeah, give me this one. Right. And this is going to be 90 cents an hour. It tells me, well, you know, it's okay. Here's the size. Here's all the other things it has. And I can review and launch. I can kind of go and configure things piece by piece. This is outside the scope of our tutorial. Like we want to create a new virtual private connection or a subnet to host it on. We can do all these things. Typically, as a machine learning engineer or a data scientist, you will not. You will use whatever configuration your company already has set up, and you'll keep things fairly safe. If we just review and launch, well, again, I'm on the free tier, so it's going to say, not without a credit card. For instance, if I did a CPU-backed one here, that's totally something I can do. So we've now talked about that. We saw that like S3 is easy, EC2 is cool. It's got some things that make our lives easier, but that's a lot of configuration, right? That is a lot of crap to understand and to have to deal with every time you want to, create a new virtual server. Now, once you've got it created, you can just turn it on, turn it off, turn it on, turn it off. Everything stays the same, right? You're good there. But doing that is a lot, right? And having to set it all up is a lot here. And if only there's an easier way. What we really want is, listen, give me a place to put my data, give me a Jupyter notebook in the cloud, give me access to a TPU, and then we'll see later on that one of the very important things is, okay, I got a trained model, make it easy for me to expose an endpoint where people can use my model for inference here. So Amazon, one of the reasons we chose AWS for this training here is that while Google Cloud and Microsoft Azure are phenomenal services, they got all kinds of cool stuff. I think SageMaker is the best data science and machine learning tool under the sun. I really do. So SageMaker, you guys could spend, I mean, we could do a full 40-hour class just on SageMaker on all the cool things it has, but I can't recommend it enough. So whereas we could, and what we just demoed was going through and creating an EC2 instance and configuring everything ourselves, we were doing the management then, right? And that means we're only as good as our own skill set. SageMaker is phenomenal because it does fully managed instances for data scientists. I don't know about you guys here, but I am very much a data scientist or a machine learning engineer at heart. I did not come up and spend years as a software engineer. I do not have a PhD in computer science or 10 years of resume experience as a DevOps guy. A lot of this stuff is very hard for me, right? So I was ecstatic when I saw that they have a system that makes it very simple to say, hey, let's only add the complexity that's needed for your job. I don't need to worry about virtual private connections and subnets. But I do need to say, well, I need this sort of machine, and I want this sort of kernel, and I want these packages. I want to use this AMI per se here. They do that for you. So you can think of SageMaker as a fully managed service for doing data science on EC2 instances. I used to do my own EC2 instances and install the stuff and run the Jupyter notebooks and all that. Now I don't do any of that anymore. I use SageMaker full stop. It is phenomenal. I can't recommend it enough. So let's look at some of the cool things it can do. Okay. Now you'll see there's all kinds of tools it has here, right? From like labeling jobs, like the ground truth service, to, we're going to focus on notebooks, but they'll do things like hyperparameter tuning for you. Instead of you having to write code to hyperparameter tune, you just tell it, here are the things to tune, here are the ranges to try, go. And it'll come back. It'll do it on the cloud and it'll come back and say, yeah, here you go. Here's a tuned model. Here's your best choice. We'll see it's very easy. We won't do this today, but in a future training, once we've trained a model on data from an S3 bucket, trained it, tuned it, and we'll do an endpoint here. We're going to do a whole class just on model productionization and shipping models per se. We'll see that SageMaker is by far the easiest way to do this. That's impressive, knowing that the traditional way to do this is to create a bare bones Flask server that's like 10 lines of code and then ship it that way. This is simpler. It's literally like, click a few buttons, and as long as you trained your model, loaded it into SageMaker, it's very easy to do. So the thing we're going to focus on today is notebooks. Okay. So they have an IDE, which is basically their own version of Jupyter Lab IDE, called SageMaker Studio. So I'm going to show you the notebook instances we can spin up, but then we're going to end by going through SageMaker Studio and seeing some of the cool stuff we can do there. Okay, so I can click on this here, or I can go over here. These are going to be the same thing. So I'm going to go to notebook instances here. And if I want to look at, this is one that I created before just to practice on some stuff here. And we can see it stopped, so I'm not getting charged for it. All right, let's create a new one. So I'm going to create a new notebook. I need to give it a name, right? And I'm going to say ES Training Notebook Example 1. I'm going to choose the instance type, right? And again, I can go down to these accelerated computing. Accelerated computing is anytime you see the word accelerated, that means hardware accelerated. That's a dead giveaway for this is a GPU or TPU machine. The larger the numbers, the bigger the memory. Now again, because I'm on a free tier, and I assume as you all are learning this, you'll be spinning up. You will be too. You need to request to move off a free tier and to select ones like these. But essentially, we can create one like this. I'm not going to do inference, but they do have servers that are just optimized for inference. So, we've spent most of our trainings the last couple weeks here talking about model training, but that's only the building of it. If you think about, you train a model and that model goes into production, really the most important part is people using it, and that's referred to as inference, right? And if I have 10 people a second asking my model, hey, what is this, a hot dog or not a hot dog? Or if I have 10 million people, those are two very different workloads here. So they have different servers for those things here. And obviously it auto scales if you want to set all that up. I'm going to have to set these sorts of things here. Typically it does all this for you. Now this is one thing I find very useful. Let's say you already have your code in a Jupyter notebook somewhere, right? Or excuse me, in a Git repo, right? So you've pushed your code and you've gone ahead and you've pushed those Jupyter notebooks to Git. You can actually clone a repository and it'll load it and start the instance in that exact repo that you've cloned, which is awesome. So I can literally just put in like the GitHub URL that we have here and it'll load it right up. Okay, so that's super cool. And then, so I'm not going to do that here. We're just going to go ahead and let me go none, just to see what this looks like here. And let's create a notebook instance. Okay. Now we're seeing this is pending, and this is going to take a couple minutes to provision. You will definitely get used to waiting a little bit here as things provision when you're working through AWS. Super cool. How much time it saves us overall, but you will do some waiting every time you click create. But so as this provisions here, this will take probably about 1 to 2 minutes. And then we'll see this will change from pending to running. And once we do that, this will change from a dash to something that allows us to open it, right? Now, while we're talking here, this is a good time to show you guys how to stop things and turn things off. So I can click on one here. If I go to actions, I can start it. I can update the settings on it. I can add or edit tags. Tags are how people typically organize things in a very large organization inside AWS, and I can delete it. So I don't need this one here. Now, it is not running. If it was, we would see start grayed out and stop and, open, and with these top 3 would be ready to go. So I'm going to go ahead and delete this one. All right. I don't get charged for it existing. That's fine. It's there. It does typically store your work somewhere. Like if you have a notebook that's there, and that notebook itself is going to live somewhere, typically in an S3 bucket. But the charges for that are minimal. It's like, very, very, very cheap. So typically it's good to keep organized, keep things clean, keep things ready to go in that respect. While this is still pending, let's talk about some of the other things here. So, JK, I see that you are asking about recording. Yeah, we'll make sure we get that to you. We send out an email blast every time these are done here. My name is Mike, and the other presenter here is Suji, and we are with Elephant Scale. Okay, so thank you. Hopefully you're, if you have any questions when you watch the recording, feel free to shoot us an email. We're happy to answer them for you. Okay, so while we're waiting for this here, and I'm trying to just fill time, let's talk about some of the other cool things this can do. So we're going to end by talking about SageMaker Studio. So I'm going to save that because that's got it all wrapped into one. But typically, you can break down everything you would need to do in data science into generally these areas, right? You're either going to, so, you know, if you have a problem, you say, hey, we're trying to solve problem X. Then it starts by figuring out like, well, do we have a data set to work off of? If you do, great. Typically, though, in the real world, you don't. And that means you have to pay people to do this for you, right? So this is a whole thing, right? When like OpenAI is doing something with computer vision, somebody has to label those images. When Cruise or Tesla is doing things with self-driving and drawing bounding boxes around pedestrians versus the road versus stoplights, somebody has to do that, right? Labels are typically generated by humans. AWS has a wonderful workflow for doing this here. Their ground truth system that's inside of SageMaker, and it can save you a bunch of time and money. And the reason for that is that they got some really powerful algorithms behind the scenes here, and they can do things like you can say, well, I have this data set of pictures. I need people to label them either cats or dogs. Well, there's going to be easy ones there that a computer could probably do, and there's going to be hard ones where you need a person to review this. So you can set thresholds, and you can say things like, hey, only ones that are, let's say, if you're 80% sure or above, it is a dog or a cat, go ahead and just label it. If it's that sure, the machine's probably right. Anything below that, I want you to mark, and humans are going to review here, and they're going to label it. So ground truth is awesome. We've talked about notebooks here. We're working through them here. We can clone from Git repos. We can manage these here, do all kinds of stuff here. We're going to move on to training in a future one here, training and inference. Okay. And then typically you have things like for augmented AI. This is a great question of essentially like, well, maybe that's what I have is what's called the human in the loop workflow. How does that work? Right. So when are these things being sent to humans to review, and when is the AI taking it? How are we setting this up? How do we make sure the human reviewers understand their job? How do I make sure that human reviewers aren't making mistakes, right? So maybe I have every picture that the computer isn't sure about labeled by 3 or 5 humans, right? You can set all these things up here, and it makes it easy. And then finally, the marketplace. Marketplace is awesome because, you know, maybe you need to model this, you know, I need something for forecasting, you know, the temperature tomorrow. Guaranteed someone's already built that. And rather than you train it from scratch, you can always look at the marketplace and go, oh, I'd like that, please. Same with data sets, proprietary data sets, algorithms, probably, it's all there, right? So this is, I highly encourage you to take a look here if you have a business problem you're trying to solve. See if any of these are a direct fit. And if they are, great. You know, that you can know what you're getting into and investigate that and figure out if that's a better, a cheaper way to do it. I see a question from Al. He says, do ML jobs get executed in a SageMaker notebook now? I'm going to schedule the ML endpoint to start up. So let's see here. If you're talking about like for trainings and things like that here. So this is all still happening on an EC2 instance under the hood, right? SageMaker is just a platform that is built on top of EC2 that pre-installs a bunch of the packages and tools that we need. So that would be things like, you know, Jupyter or Jupyter Lab. And we'll see, like in a SageMaker Studio, we have all that ready to go here. We'll see that the experiment section of that, for instance, is really just handling all our training sides here. Like, for instance, you've got very low code or no code solutions there. So here's my data, here's my solution. You can do things like find me the best algorithm for this here, and it'll recommend you should use XGBoost. You should use a neural network with these parameters. It'll do these things here, and then it is quite easy for you to turn around and say, I'd like to productionize these. These are the types of endpoints I need. These are the parameters here. That's a bigger conversation here. Luckily, I will say the inference section has amazing documentation, and we'll likely cover this at a later point here. It's kind of out of the scope of our training today, but typically, whatever you want to do here, you can configure it that way. So they've done a great job of giving us the tools, but not necessarily making sure that, not forcing us to do it their way. So let's continue on here. Our notebook is ready, so I'm going to open Jupyter. Now, I don't have any notebooks here, right? But we've all seen this familiar screen from starting Jupyter. Typically, if I wanted to create a new one, I could do that. These are the kernels that are pre-installed, right? So if you wanted to use the Deep Learning AMI, these are them, right? These are different ones here. So for instance, this is one where it's going to have TensorFlow with Python 3.6, TensorFlow with Python 2.7. Here's versions that use Conda with TensorFlow 3.6, TensorFlow and Python 3.6, PyTorch, Chainer, all kinds of good stuff here, right? R, if you use R, I'm sorry. I always found it a bit harder to do deep learning in R. But essentially, so we can have these things in here. Now, one thing that I do encourage you all to do if you're new to SageMaker and to using basically this cloud platform here, take a look at their examples section. This stuff is absolutely phenomenal. They have examples for so many different things that you could have here. And again, this is just the top section of like introduction to their algorithms here. Now, SageMaker itself is not just a platform, it is a library. And if you use it, you'll see SageMaker is a library that wraps TensorFlow, it wraps PyTorch, Chainer, all these good things here. And let's look at one, right? So let's start with, let's do an image classification, one with full training. Now we're going to see they use SageMaker and they create an estimator object from a TensorFlow model, right? It's very easy to do that. They might use PyTorch here. I'm not actually sure. But this is just documentation. You can take this, you can look at it, you can run it. We can open this here. And we see there's Bodo 3. So they're doing a lot of the things that we do with the GUI. You're seeing they're actually doing some of these things like upload to S3 bucket. They're doing that with a function, and they're using the Bodo 3 library to do that. And then we just see this is kind of how they're going through this stuff here. Now, they're again using their SageMaker estimators here, which is a bit more advanced, typically to wrap a training job in that. However, it is something that you'll get there eventually, and it's not crucial that you understand how to do that right now. You can certainly do machine learning and TensorFlow and Productionize, all those things without using it. Typically, I don't reach for the SageMaker library that much as is. But again, this is just one of these notebooks here, and again, there's got to be 100. There's probably way more than 100, probably many more. So if you just wanted to master, for instance, the Python SageMaker SDK, here are a ton of examples here. I'm sure we'll see Keras or TensorFlow mentioned. There's MXNet. There's all kinds of other good ones here. PyTorch, yep, here's all the TF stuff. So very, very cool there. This is useful. We're getting more useful, but this is still kind of like, well, I got to do everything. I got a Jupyter notebook. I still have to, when I'm done, I have to save the model to an H5 file. I have to move it. I have to do all that stuff here. This is better, right? But it's not fully managed like we talked about. So let's look at, I'm going to close this out. I'm going to go back here. I am going to turn this notebook off because I am not made of money. Stop. And then we're going to go into SageMaker Studio, and we're going to see just what that can do and how it kind of wraps all these things together under a single integrated development environment for us here. So while that's stopping, I'm going to go ahead and load up SageMaker Studio. Now, SageMaker Studio is something that came out recently, and they've been iterating on it here. I've left this up and running, so it should be good to go. I'm just going to open the studio. Okay, we saw that it was ready. We have the check mark. And for the money, I think that this is probably the most useful tool set in the kind of the machine learning world right now. And I'll show you why. Now we can, if there's interest for it, This is certainly something we can consider doing a more deep training on later. But this is an example of kind of what it all looks like. So this is SageMaker Studio. So when I say this is a fully managed instance of an EC2 container here, I truly mean that. I can change over the kernel I have here, right? And I can say, like, what kernel do I have? Oh, it looks like my graphics card doesn't like me running Zoom with this here. But I can go and say, for instance, I'm using TensorFlow 2 GPU optimized. Great. And I've selected that, right? What machine am I running it on here? What instance type? And we see here are my options, right? So here's a GPU-backed one. The others do not have that. We can see here how many virtual CPUs or cores does it have, how much memory. I'm going to click that one. And I'm going to save and continue here. Pardon me. Now, let's say we need to do something in the terminal. This is not just a Jupyter notebook. I can click on this guy, launch terminal and current SageMaker image. And this is now just as if I am talking directly to the Docker container. This is that. And I can do something like, you know, PWD. And I can see LS. What are my things here, right? You name it, I'm in that. I can do all this good stuff here. Let's see, ls-a, what hidden? And there's all some of the hidden files, right? So very, very cool. I'm inside of the Docker container. If I needed to pip install or conda install something, I could do it here from the terminal. You can also, if you're clever, run those directly in your notebook cells if you're looking for certain things. And it'll tell you what sessions do you have open, right? So here we see this wasn't open before, right? I'm going to close that, but we see this is still here. I can now shut down that kernel, or excuse me, that terminal session. And it'll take a second to catch up here. So, you know, we have the image, we have the kernel. This is like the actual Docker image. This is the kernel session, the notebook I'm running at the given time. All right, the kernel is powering the notebook here. It tells me what machine I'm running it on, you name it. Now, there's all kinds of awesome stuff here, right? This is just to make it easy to understand what to use, what the commands are. The experiment list, I think, is one of the coolest things. Now, again, this is outside the scope of our training today here, because again, we could talk about this for 6 hours easy, just all the different cool things you could do with SageMaker Studio experiments. However, let's give you a quick demo here. So I can name an experiment. I can point it towards an S3 bucket and what keys I want here. Now, again, I don't have any data in those here, so it's not going to be there. And then I can tell it, select the machine learning problem type. I'm doing a multi-class classification task with, I want a F1 score. And then things like that. So I highly encourage you all to play with this here because this is, I think this does a great job competing with like things like Data Robot or other low-code automated platforms here. I, as a data scientist, I know a lot of data scientists, machine learning engineers do not like the low-code, no-code solutions. However, I'm somewhat in that camp. However, I think that this is a very elegant way to handle it because there are things where I don't want to do all of this work here, right? Like, for instance, if you want to benchmark the best shallow algorithm against your TensorFlow model, how does, you know, well, would it be XGBoost or is it a Bayesian classifier, things like that? It's kind of up to you to figure that out, right? And typically I'm used to having notebooks where I'm just running all that crap at once and just seeing which one did best. Now, here I don't have to. I can just say, hey, find me the best, go. You can run different experiments. You can change things out. It'll tell you and keep very good job of tracking these things here. But I encourage you to look at the docs on this here and the YouTube videos AWS has out. These are very helpful. And if there's anything specific you guys are looking for that piques your interest here, let us know. We can always answer questions. And certainly this is something we can offer training on here to make sure that you guys are not just doing good machine learning on the right platforms, but doing it in the most efficient and fast and effective way possible. So I'm going to close that here. We see there's other things we've got here, notebook tools, SageMaker endpoint list. Al, to your question here, you can basically productionize a model and create an endpoint right here without ever leaving SageMaker Studio. It'll give you the lists of them here. Again, we're not going to go too deeply into this here. Hopefully, we find time to run through this in a future training. But you can literally productionize your endpoints, keep them listed here. You can update what models those endpoints are pointing towards, what parameters are required, all of this good stuff. This used to take a lot more time. If you guys were doing deep learning or machine learning and you're productionizing endpoints on a cloud platform like this 3 or 4 years ago, this was a much longer process. So anything that allows us to control and tighten up that feedback loop, right? I mean, a solved Jupyter notebook does not make companies money. Just make data scientists feel like we've done something cool. But it doesn't affect the company until people can use what we've found, what we've discovered, right? Until we share it. So anything that allows us to productionize and throw up endpoints for these models more quickly is absolutely awesome because it closes that feedback loop. It allows us to say, actually, our model isn't working the way we wanted in the real world. What data are we missing? How can we make this better? Or maybe, yeah, it is, but we need it to be faster. How can we affect the latency? You can't answer those questions, which I think are really the most important ones, until your model is live and people are using it. So SageMaker is great because we can kind of run right through it and do all that. Now, this is a notebook that I put together here just to train a basic example here. I built a fairly large, by MNIST standards, convolutional neural network that should have taken about, 3 to 4 minutes per epoch on a CPU. We're running this on a heavy duty machine and we see that the training times are a lot lower. And you see, this is the exact same code that we write in a regular Jupyter notebook. There's no extra work here. There's no extra configuration. We can just do what we do best. Here I import everything I need. I check my versions are right. Make sure you do that. That's helpful. Downloaded the data, pre-processed it, reshaped it to have that extra 1 dimension because it's grayscale, so my model doesn't complain. One hot encoded my labels. Again, this is a review. We've done all this before in previous lessons here. If you're confused by all this, I encourage you go back, watch videos 1 and 2 in this series here, and you'll all understand all this quite shortly. So here we built the model. Right, we did a summary. We see everything looks good. About 640K trainable parameters, but a lot of them are conv layers. That's going to slow things down. And we can see we are very much on a GPU. This is, 8 seconds per training. That's pretty good here. We get to a validation accuracy of 92. We can spin up TensorBoard right in here if we wanted. So next steps would be to save the model and productionize the endpoint. You can push it right to Git. You can look at diffs of your notebook here. So if you've ever, this is one of these tools I think is very helpful. I'm seeing it blanked out because I did not, this is not in a Git repo right now. However, if you're using a Git repo or something like AWS Code Commit for version control, if you've ever run into a merge conflict in a Jupyter notebook, you know that it is absolute hell because when you look at the diff, it's all a bunch of JSON. Jupyter notebooks are stored as JSON under the hood describing each cell. And finding where the merge conflict is can be very, very challenging. So you can actually, with this here, use a tool called NBDiff, and it'll show you a visualized version of where these notebook cells are different. It is much, much easier to debug with this tool. And here they understand that, to me, with them including this on the toolbar, says to me that the people who built this system truly understand what my job is and what my biggest challenges and annoyances are. Because this is a tool that just easily could have been hidden in something over here, but realistically, this is something that'll put the brakes on your day if you have a merge conflict because you changed a typo or something like that and didn't mention it. So these have all these things here, all the same things we can do with running the kernel. This all feels very familiar to us. But when we can do these things and the other added bells and whistles that we'll add in a later training, you'll see it's just phenomenal. Some of the things we can do. We can convert them to slides, all kinds of fun stuff. So that is the end of what we have to demo for today. Today is, again, as we said, a bit of a shorter one. We wanted to make sure we had a bit of a breather. Our next lesson will be a bit heavier duty. But I thought this was a great place to make sure that you guys understand the tips and tricks and tools that are out there. We've taught you all how to use TensorFlow, how to use GPUs with TensorFlow, how to really write good code that works like a good deep learning engineer. But doing that on its own is 40% of the battle, if that. You have to be able to use the professional tools, or else you're going to struggle to make use of all this excellent knowledge that you guys have worked hard to get. So this is a great way to kind of ease into it here. Generally at this point in these classes, people ask me, Mike, what are some ways I can practice and make sure that I can show myself, okay, I can do what needs to be done here, okay? And some of the things we'll look forward to doing in a future training, but I encourage you all to try now on your own and work through the AWS documentation, is to do things like load data to an S3 bucket. Get the AWS command line tool working up and up and running on your machine. Be able to spin up a bucket and throw data into it. Train some models inside of SageMaker. I really think these are great ways. And by the way, train that model on data that you stored in that S3 bucket. If you can do those things, you can do a lot of the challenges. I'd say 70, 80% of what a machine learning engineer is going to have to do on the job, right? The data may change. The classification and regression tasks you're solving may change. Certainly the model architecture will. But at the end of the day, the tools you'll be using to do these things, they're going to stay pretty static. No matter what your data is, it's probably coming from an S3 bucket. No matter what model you're using, you're probably building it in SageMaker. So these are great things that you can do. And again, AWS does have a free tier to allow you to practice and try these things. If you can do those, then you're in a really good spot where you are doing not just machine learning tasks, but you're doing them using professional quality tool chains. And then, finally, and this is something that I think is very hard to get to on your own, but certainly this is something we'll try and cover in the future here, is how to productionize models from all this here. And that is a separate topic all on its own. We do plan on doing a day just about all the different ways you can productionize a model. So that is the final part. And if you can get there on your own right now, great. It's certainly worth the practice. And you'll see, if you know how to do that already, that there are some wonderful value adds that this service provides. If you don't worry, we'll get you there, okay? And you'll be able to see by the end of this here that not only can you put these models live, but that this makes it pretty easy to do so. So that's all we have for today here. We'll certainly open the floor for any questions that you all might have. I understand this was a bit more of a kind of a theory, less of a theory day and more of just a survey course here, if you will. But I think that this is definitely something that will make you all be able to move that much faster when we do get into doing these things on these services here. So if you have any questions, feel free to fire them off here. I will wait around until we go a couple minutes with no more questions, and then we'll call it a day. Al asks, how do I bring in my own Docker container with an ML framework to run in the studio? Excellent question, Al. So it does support the ability to run your own containers there. I'm not quite sure how you do it directly in SageMaker, although I know for a fact you can do it. I've been at the AWS pop-up loft in San Francisco when they're talking about this specific thing here. So basically, you would import that as an AMI just like any other thing here. I don't know if that means uploading it to their marketplace and using it that way, or if there's a private way to do it. I'm sure there is. This is something that I do not know off the top of my head, although I'm sure we could Google it and find the answers in the AWS documentation. But certainly I'd encourage you to take a look at the AWS docs, search for that. Like, I would search for SageMaker custom Docker container or something like that. And you'll probably see the answer right there. If you can't find the answer, go ahead and shoot us an email and we'll see if we can't help you figure that out. But great question, and it is something you can definitely do. I'm sorry I don't have the answer off the top of my head right now, but there's a lot of different configuration things you can do here, and we're learning all the new tips and tricks this came out with too. So, great question. let's see if I can find that answer for you while we're waiting here. Now, let's see. Looks like it. Yep. Create Docker containers with the Amazon SageMaker containers library. So yeah, makes sense. They have a tool just for this here. I will go ahead and again, this will be in the video, but I'll drop this in the chat for you, or better yet, I will answer your question directly with it. And while I haven't worked with the SageMaker containers library, it looks like this documentation is very good. Run pip install SageMaker containers, and you can just kind of say what you need here. And this walks you through it. But it looks like that is something that you can absolutely do. So hopefully this gets you where you need to go here. Looks like you can also use your own inference code too, which is awesome. So hopefully that helps you, and hopefully that answers your question. All right, it looks like that's all the questions we have, everybody. So we're going to call it a day here. Certainly, if you do have any questions that you'd like to ask, you're always welcome to email us, ask them offline here. We're always happy to chat. And again, if there's hopefully this series here has given you a lot to think about how you guys can use machine learning workflows and tools in your own workflows and at your own companies here. Certainly, if there's any questions that we can answer or things we can do to help, that's what we're here for. So thank you all so much for taking the time for another great class, and hopefully we'll see you same time next week. Thanks, everybody. Have a great day.